We're going to continue our discussion of factoring, or writing things as a product, by talking about factoring trinomials. And a trinomial is something with three terms. However, before we dive into the factoring problems, I want to start with one quick review problem. I want to remind us how we multiply two binomials, things with two terms. So if I want to multiply x plus 2 times x minus 10, some of you might have learned this FOIL acronym. It stands for first, outer, inner, last. But basically, it's just reminding us that we have to distribute every possible combination of terms. In other words, we multiply the first two x's together to get x squared. The outer terms, x times negative 10. The inner terms, 2 times x. And the last terms, 2 times negative 10. Finally, we can combine the like terms. Minus 10x plus 2x is minus 8x. Now there's a pattern I'd like to point out. Notice that minus 8 in the middle term came from a negative 10 plus 2, but the constant negative 20 came from negative 10 times 2. So basically this pattern is saying if we want to factor a trinomial that starts with an x squared, a 1x squared, we can factor it as two binomials, two things with two terms. And the numbers that are going to go inside those parentheses, what I've written as m and n, are always going to add up to the coefficient of the x and have a product that is equal to the constant. And so let me just show you how this works with an example. Example 1a. I have a trinomial that starts with a 1x squared. And so I need to find two numbers that have a product of 2, the last number, and a sum of the middle number, 3. So I start by thinking of all the ways I can get a product of 2. And there's really only one way we can get a product of 2. That would be 2 times 1. Fortunately, 2 plus 1 is 3, so those are the numbers. That means my factors have to be x plus 2, x plus 1. Example B, x squared plus x minus 20, trinomial, three terms, starts with an x squared. So I can factor this as two binomials, both starting with x's. And then the numerical part, the numbers that go in the parentheses, have to have a product of negative 20 and a sum of 1. So I start with the product, and I list all the ways I can get a product of 20. 1 and 20, 2 and 10, 4 and 5. But it's a negative 20, so one of those numbers has to be negative. I need a sum of positive 1. To get the numbers to add up to a positive number, the smaller number must be negative. So negative 1 and 20, negative 2 and 10, negative 4 and 5. And the only one that adds up to 1 is negative 4 and 5. So my factors are x minus 4, x plus 5. Okay, my next example, example C, looks a little bit different because that first term, the n squared, actually has a number in front of it, has a 2 in front of it. However, in this problem, 2 is actually a common factor. In fact, when we're factoring, we should always look for a GCF first, a greatest common factor. All three terms are divisible by 2, so I'm going to start by pulling out the 2. That leaves me with 2 times n squared minus 9n minus 36. So now I need to find two numbers that have a product of negative 36 and a sum of negative 9. So I make a list of all the ways I can get a product of 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And this time I want a negative sum. So that means the larger number has to be negative. Of this list, 3 and negative 12 is the one that adds up to negative 9. So in factored form, I'm going to keep that GCF, the 2, in front of the problem, and then the trinomial gets factored as n plus 3, n minus 12. Now my second example is a little bit different from the previous examples, in that there's a number in front of the x squared. We have a 5x squared, and there's no GCF. I can't actually take the 5 out of the problem. So instead, I'm going to use something called the AC method. We start by multiplying the first number and the last number together. 5 times 7 is 35. So now we want to find something that has a product of 35 and a sum of that middle number 36. The numbers 1 and 35 will work. So now I just copy down the first term of that trinomial, and then instead of the middle term, I break that up into two terms using those two numbers that I found. So instead of writing 36x, I write 1x plus 35x. And then we copy down the last term. The reason we've done this is we've now taken something that had 3 terms and written it with 4 terms. This is a good thing because we have a method for factoring 4 terms. We can use that method of grouping. First 2 terms, I can take out an x, and I'm left with 5x plus 1. Second 2 terms, I can pull out a positive 7, and that's good. I'm also left with 5x plus 1. Because I have the same thing in the parentheses, I can pull that 5x plus 1 out front, and I'm left with x plus 7. All right, let's take a look at another example. In this problem, once again, there's no GCF, nothing we can take out of all 3 terms, and there's a number in front of the a squared, 4a squared. So we're going to have to use the AC method. So I need to find 2 numbers that have a product of negative 24 and a sum of negative 5. So I go through and make a list of all the ways I can get a product of negative 24, and one of them, the 3 and the negative 8, add up to negative 5. So we're going to use those 2 numbers to break up that middle term. Copy down the first term. Instead of the middle term, I write plus 3a minus 8a. Copy down the last term. I'm going to now use the grouping technique, and in the first 2 terms we can pull out an a, and we're left with 4a plus 3. I'm going to take a negative 2 out of the second 2 terms, and that'll change the signs. Pulling out a negative changes the signs. So now I also have a 4a plus 3. The 4a plus 3 comes out front. We're left with an a minus 2. And that's our answer in factored form. All right, next example, example C. Well, the first thing I'm going to do in this problem is try to find a greatest common factor. Right away I notice all 3 terms have m's in them. So we can definitely pull out an m, but we can also take a 4 out. So 4m is my GCF. So I pull out the 4m, I'm left with 11m squared minus 2m minus 13. Once again, there's still a number in front of that m squared, so I have to use the AC method. 11 times negative 13 is negative 143. So I need 2 numbers with a product of negative 143 and a sum of negative 2. Oh, and in this case, it turns out that those 2 numbers we started with, 11 times negative 13, do add up to negative 2. So I'm going to copy down the GCF because that's not going to go anywhere. I don't want to forget about that. And then copy down the first term. Instead of the middle term, I write plus 11m minus 13m. Copy down the last term. Now I can use the grouping. I can pull an 11m out of the first 2, left with an m plus 1. And if I take a negative 13 out of the second 2, I am also left with an m plus 1. And finally, make sure you include that GCF in your final answer. The 4m doesn't go anywhere, just stays in front of the problem. Okay, so the theme is look for a GCF first, and then if there's a number in front of that x squared, or m squared, you have to use this AC method to write it as 4 terms. If there isn't a number in front of the x squared, you can just go straight into kind of a guess and check where you just find the 2 numbers and plug them into the parentheses. So my last example looks a little bit different because this problem has an x to the 4th in it. But it turns out we can use the exact same factoring methods here. So first of all, there's no GCF. There's no x with the 6. I also notice there's no number in front of the x to the 4th. So I'm going to just draw my parentheses right away. If the first term is an x to the 4th, that actually means you have to have x squareds inside the parentheses, so that you get that x to the 4th product. Now I'm going to try to find 2 numbers that have a product of 6 and a sum of 5, looks like 2 and 3 work. So my factors will be x squared plus 2, x squared plus 3. So notice that the process is nearly identical here. The only difference is I had to put those x squareds into the first place. Now, if you prefer, you actually could have used the AC method in this problem. I'm going to quickly show you what that would look like. You would copy down the first term, x to the 4th, and then instead of that middle term, we would use the two numbers that we found, 2 and 3, to break it up into two terms, 2x squared and 3x squared. Notice that the middle term has an x squared, so those two terms have to have x squareds. Copy down the last term. I can take an x squared out of the first two, a positive 3 out of the second two. I can then bring that x squared plus 2 out front. I'm left with x squared plus 3. So that's it for my examples on this particular section, but as always, please stop by or send me an email if you need help with these topics.